Okay, so on page, here we go, 533, number 14. The prime area of a transformer has 150 turns, so that's your NP. It is connected to a 120 volt source, so that's your VP. Calculate the number of turns on the secondary, NS, is what you're looking for. Needed to supply these voltages, so we have three different ones. So for A, so we're looking for NS, so it's going to be NS over NP is equal to VS over VP. Bring your NP up. Okay, so NS equals, so in part A, V is 625 VS, and VP, they gave us 120, and my NP, 150. And when you do this, you get 781.25 turns, so 781 and a quarter turns. And a quarter turn is possible, you just don't, you come off the coil in a different spot than where you started. B is going to be exactly the same thing, just reusing this. NS is going to equal VS over VP times NP. The only thing that changes is in B, the voltage is 35 volts over 120 volts times 150. And when you do this, you get 43.75 turns. So 43 and a quarter. And the same idea with C again. So NS equals VS over VP times NP. So NS equals, my VS this time is 6 volts over 120 volts times 150. So 7.5 turns. Okay, that's it for number 14. Number 15 says, a step-up transformer has 80 turns on its primary. So in primary, 80 turns. And 1,200 turns on its secondary. In secondary, 1,200 turns. The primary supplied with an alternating current, so V primary, 120 volts. What is the voltage across the secondary? V secondary over V primary is equal to N secondary over N primary. Multiply both sides by V primary. So V secondary equals 1,200 over 80 times 120. 0, 0, so 144, but then 8 goes into that, 1800 volts, I think. Okay, there's a B part that says the current in the secondary is 2 amps. So I secondary, 2 amps. What current flows in the primary? So I primary over I secondary equals, and it's the N's we were given again, so N secondary over N primary. Bring your I secondary up. I primary is equal to N secondary 1200, N primary 80, and I secondary 2. So 24 over 8 is 3, 1 0 cancels, so I think we get 30. So the current in the primary is 30 amps. And there's a part C. What is the power output and input? So it's asking for power in the primary. Power is IV. So power in the primary, the current in the primary, 30 amps. Voltage in the primary was 120 volts. So it should be 36 with 2 zeros. 0 watts. Doing the same for the secondary. I secondary, V secondary. I secondary was 2 amps. V secondary was 18. 1000 volts, power in the secondary 3600 watts. When the two powers are equal, it's called an ideal transformer. Okay, and this is a step up because the voltage has gotten bigger. Number 16 says a portable computer requires an effective voltage of 9 volts from the 120 volt line. So now the question here, it's the first one where they actually haven't come straight out and told you which one's which is the primary and which is the secondary. You actually have to read the question. So a portable computer, nowadays known as a laptop, requires an effective voltage of 9 volts. It's what is needed to run the computer. It's going to be your secondary. And then it says it's from a 120 volt line. So the 120 volt line is the primary. It's what's coming into the transformer, and then coming out of the transformer has to be 9 volts that you can use. If the primary of the transformer has 475 turns, so 475 turns, how many does the secondary have? So N secondary over N primary equals V secondary over V primary. Bring the N primary up. N secondary equals 9 volts over 120 volts times 475 turns. And when you do this, you should get 35.625 turns. Okay? There's a B part that says 125 milliamps. So 0.125 of an amp. That's your I. 125 milliamps flows through the computer. So that's your I secondary. Because it's going into the computer, which is what's coming out of the secondary coil. What current flows through the transformer's primary? Okay, so I primary over I secondary is equal to, this time I'm going to use V's because that's what they gave us. So V secondary over V primary. Bring your I secondary up. So I primary is equal to 9 volts times 0.125 amps divided by 120 volts. And when you do this, you should get an I in the primary to be tiny, 9.375 times 10 to the negative 3 amps, or 9.375 milliamps. Okay, and it should be less because the voltage is going down. The current should go up when you go from primary to secondary, which it does. All right, and that was the end of your homework questions.